So POCl3 has the skeleton structure depicted here. What is the Lewis structure for POCl3 following the octet rule? And what are the formal charges that causes on all of the atoms? And what is the Lewis structure for POCl3 in which all formal charges are 0? So let's go about that. So as usual, we're going to want to start with our valence electrons. We're going to have 5 from the phosphorus by 1 because there's only 1, 6 by 1 because of the oxygen, and 7 by 3 because of the chlorine. You can go ahead and label this. This is POCl3. And this is actually going to give us 21 plus 11, so 32 electrons. So we have 32 electrons to play with. From this, we can quickly figure out which one is the central atom. It can make the most bonds. For phosphorus, that's going to be 8 minus 5, so it can make 3 bonds optimally. Oxygen, it can make 8 minus 6, so 2 bonds optimally. Chlorine, it can make 8 minus 7, so 1 bond optimally. And so we're going to have P in the middle. We have 3 Cls, and we have 1 O. Let's start with 1 bond on each of them, and fill in our octets. And this is what we're given as the Lewis structure following the octet rule. And so we have 2, 4, 6 by 4 plus 8. That's going to give us 24 plus 8 electrons, and that is the 32 electrons that we have. So this Lewis structure does work. Now let's double check on the formal charges to see if it's the lowest energy Lewis structure for this molecule. And so on our formal charges for the phosphorus, we are going to have 5 minus 0 minus 8 over 2. That's going to be 5 minus 4, giving us a positive 1. So the phosphorus is going to have a positive charge. Let's double check on the oxygens. We'll have 6 minus 2 over 2. It's going to give us 6 minus 7, giving us a negative 1. And now let's see the chlorine. We're going to have 7 minus 6 minus 2 over 2. That's going to give us 7 minus 7, which is 0. And so the formal charges make sense. The structure given in the question doesn't have any charges. These two charges would cancel, yielding a net charge of 0. But from this, we can also tell that this is not the lowest energy structure for the molecule, because in order for it to be the lowest energy structure, we'd like to neutralize these charges somehow using different electron arrangements, so we can bring the formal charges on each of them to the lowest value that they can be while still maintaining our valence electrons. And so we can do that if we make the decision to cancel out one pair of electrons here and actually cause a double bond. Now, this would imply that phosphorus has more than the usual 8 for an octet, but this is going to be allowed because phosphorus can form an overfilled octet using the fact that it has d orbitals somewhere close to it, according to the periodic table. If we just check here quickly. No, it technically cannot, but it's what is asked for in the question. For what is the Lewis structure if all the formal charges are 0, and this is the structure that would allow all those formal charges to be 0. So it's just a theorized structure. And so in this case, let's just ensure all of those formal charges are 0, because that is what is asked for. And so on the phosphorus, we're going to have 5 minus 0 minus 10 over 2. And that is going to give us 5 minus 5, which is 0. On the oxygen, we're going to have 6 minus 4 minus 4 over 2. And that's going to be 6 minus 6, which is 0. And on the chlorine, we are going to have 7 minus 6 minus 2 over 2, which is just 7 minus 7, which is 0. Okay, and so if you want to Yeah, so all of this makes sense. We have formal charges of 0, and this is the structure that would allow for it. So in this state, the phosphorus is exhibiting an expanded octet, which means more than 8 electrons.